can see the screen with both of us on it.
Hey there, everybody. Good evening and welcome to...
You can see the screen.
Hey there, everybody. Hey there. There we go. We got it this time. Welcome to Livestream Building with Rex. It's a sporadic live stream about kit building and other QRP projects. My name is Charlie. Call sign is NJ7B. So with me this evening are the show's two co-hosts, Rex, W1REX, and Steven, N1SH. And I'm just muting you a couple times because there's a lot of feedback, Steven. So a warm welcome to all you guys who are watching live in the chat. If you have a comment or question, go ahead and throw that in the chat feed, and we will respond to it. We may have some audio issues, but we're going to go ahead and turn the time over to Rex, and we're going to figure it out. We may need to mute what we have up on YouTube, if we have the YouTube screen up as well, because we can't have too many audio things coming through. But let's go ahead and turn it over to Rex and Steven and see what we have. Because we have the YouTube screen up, too many audio things coming through, too many audio. Let's go ahead and turn it over to Rex and Rex and Steven.
Okay. Can you hear us?
There we go.
We've got a terrible feedback. We got an infinite audio loop here. We had all kinds of stuff going on.
Yeah, but I think we're good now.
Yeah, I can't tell if I got audio or anything on it. So I'm just gonna. Audio here. We had all kinds of stuff.
Yeah, there's like an audio delay. Keep talking.
Yeah. Okay.
Keep going.
All right. Good evening, everybody. This is W1REX and N1SH over on the other side of the computer. And this is session 2 of our Livestream Buildathon session, or number 1, I call it. So hopefully we've got, we had quite a few people send away for the kit, and almost everybody has got them by now. We've got one person in Canada that doesn't have them. We got one person in Frankfurt, Germany that didn't quite make it. But we got most everybody's got the kit. Most everybody's got the parts that were missing from last week. So anyway, we're going to start off by a couple of different topics quickly. We need to know. Can I give it overhead?
Yep.
Soldering irons. I hope everybody's got a decent iron. This is a soldering station I bought in about 1990.
We can't see that.
I know we can't see the station, but it's a Zytronic made in Sacramento, California, American company. It's an 860-watt iron, and I put it on my little borrowed kilowatt meter, and it measures 58 watts. Okay. So it's an honest 60 watt soldering iron, and it's something that I think you're going to want. Most people should be using at least a 35 watt pencil iron, 60 watt, 80 watt soldering station if they've got one. You don't really need a ton of power when you're doing these small kits because we got small pads, small traces. We don't have a lot of big ground plane. Another iron that I like that I've been buying and using in Buildathons is this, where am I? Which camera am I on? I got 3 cameras staring at me here. Okay, and there's no red LED on any of them telling me which one I'm supposed to be looking at. So anyway, this iron right here I get on Amazon, I think. Okay. It's a nice little iron. It's adjustable temperature. It's got an on-off, and it's got a digital screen on it for telling you what the temperature is and setting it. Comes with all kinds of tips, and it's like $15. But it says right here, 110 volts, 80 watts, which is a lie. This is nowhere near an 80 watt meter. And in fact, if I plug this into my kilowatt, and I checked this out on a lot of those simple meters. I'm going to plug it into my kilowatt, and I'm going to turn this iron on and hit watts. $39, $38, $37. It's going down as the temperature goes up. It's going down. But it's maybe 30, 35 watts, 31. So it's averaging right now. It's dropping down. I was getting it about 30 watts. So anyway, but it still works. It's still a nice little iron, and it works for most of the kits. And I've used it in many buildathons, and I've loaned it to many builders and buildathons, and it's been a nice little iron. But I'm going to go back to my real live Zytronic, which I, as I say, I've had for years. And okay, we get that thing. Okay, I'm going to start heating that sucker up. It doesn't take too long. All right, so again, irons. I'm not going to go through all the tools and everything, but there's one thing that I sent an email out earlier on was there's a couple of parts that you have to cut that you need some serious cutting power. So I'm going to open up the kit, and we're going to see there's a bag of parts for the kit. There's a bag for the straight key, and there's a bag for the accessories. So I'm going to set those all aside. And over here, building the RF probe very quickly. We have a little circuit board. This is a me squares board that, again, it's just a bunch of squares. You can make any circuit you want. Whoop, there it is. You can make any circuit you want with it, as long as you solder it to the right pads. One of the things that I showed in the build was to cut the little notch off the corner, only because when you have this thing and you're going inside a circuit, you want to try to get around components and stuff, and having a little notch there allows you to get closer to the part. So what you don't do, and here are my very good flush cutting nippers that you should only use to cut component leads. You should not be cutting circuit board material or connectors or anything that's got any kind of material to it, because you're going to wreck that nice little thing. In fact, here's a pair of nippers, and if I need a close up of this one. And look at it. See at the very tip right here, you can see there's a little hole in there. Whoops, right there. There's a little hole in the end of that flush cutter because someone tried to cut some sort of a piece of really serious something. I loan these out. I loan my tools. Some of these tools I loan out when I do buildathons and stuff, but I don't really catch everybody doing stuff. But yeah, so then now if I go in and try to cut leads and I accidentally get at that hole, it doesn't get cut. So this is not what I'd call a first string set of cutters anymore. So I relegate it's a fine set of cutters and they will cut things, but they're now second string. So I can use that second string cutter to go across that pad. And that will work. Okay. And I haven't wrecked my really good ones. Now, another thing you can use is I mentioned in my email that I sent as I got these front nippers. Now, these are serious nippers, and they're pretty sharp in the front. Got a really nice cutting edge. And yeah, those will take that nip off or the little corner off pretty nice. And of course, my super favorite guillotine cutters with a nice utility blade there. Yeah, see that utility blade in there? That will go in there, but you want to really go way down to the bottom to get that. And that will cut it very nicely too. But you do not want to cut stuff like that with your number one cutters. You'll wreck them. So don't do that. And don't use your wire strippers to do that either, because that's not really, in fact, you can ding up your little cutters there too. So again, the old saying, the right tool for the job.
I think I got our audio problem sorted out.
Okay, audio problem sorted out. Okay, so we'll continue on.
Yeah,
all right,
you can hear Charlie. So
we can hear Charlie. That's all we need to know. So I'm going to put those things aside. We're going to go after. We're going to build this kit, and I'm going to take it from start to finish. I don't know how many people we got building tonight. I know some people, when they got their kits, they were like really excited, and they built them right when they got them. They didn't wait for tonight. So the first thing I'm going to do is sort all the parts out. If you sort them once, and I showed this last time, and I'm going to do it again. I can't say it enough. That if you sort the parts out one time, now here's all the stuff that's totally recognizable. I don't need to write it down what it is. So I'll just take and set those aside off the screen here. And then I'll go after just the parts that are very hard to discern. So I'll take all the capacitors. Here's some chokes.
And this is to help catch up some of the people who had some questions last time,
Right.
in case they still were missing something. So we'll
Okay.
go through it pretty
And
quick.
we'll talk about a couple of these parts because the parts are different sometimes in different kits depending upon how many I had of a certain item. Like for instance, these two things that look like resistors, but they have a waist on them. Okay, like a wasp. Okay, I'm trying to show.
Camera hit.
See, it's kind of hard to see that, but anyway, they have this hourglass
Bring it in
figure.
closer.
Okay, there you go. All right,
Yeah.
they have an hourglass figure where a resistor has pretty much a straight body. So that's a dead giveaway that these are wire wound axial chokes. Okay, so we set those aside, and the body is green, so that's different. Where most of the resistors are tan. Now, if you look at the bill of materials, which you should have a sheet printed out with your bill of materials, how many resistors are there? I think there was 8. Was it 8 resistors? 1, 2, 3, 4, 5, 6, 7. How many resistors are there supposed to be? 1, 2, 3, 4, 5, 6, 7 resistors. So there they all are. So here's all the capacitors. 2 transistors. So there's not a whole heck of a lot. There's not a lot of parts on it, which is why I chose it for this Buildathon kit. It's a nice kit for doing a Buildathon or a club build. It's something that everybody can play. Whoops! Oh shoot! Okay. There's my sheet again. So one of the things that people, well, I mean, advanced age. I'm not going to say anything. I'm advanced age. I need an aid to measure some of the, or to see some of these things. But the writing on these things are really small. In this case, that's a, look at this. No, it doesn't quite work. Those are 104s. Okay. And if you know your capacitors, we'll just call it a 104. Okay. Which happens to be a 0.1. This one here is a 221. Okay, so I'm not going to write down I'm going to write down the values because if you look in the bill of materials, I think the values are spelled out on the bill of materials as both the value. See, it says 56 picofarad, and what's marked on the capacitor is 560. That's 56 with 00, so that's 56. 100 would be 101, so that's 10 and one more 0, so that's 100. So that's, I'm going to mark these things all that way. Now this one here says K2J, but that's not the value. You turn it over and you look at the other side and it says 681. So that's a 681. So I'm just writing these down and marking them, and I just one at a time. And it only takes a few minutes to get this thing squared away. That's a 560. And
the soldering iron temperature question has come up
Yes.
once again. You want to wait till we get to the soldering part? to
Well,
answer
no,
that,
I can
or-
talk while I'm doing this. 101.
Let's see. Yeah. Anybody 600, 600, anybody 600, 500, 500, 400, 300, no, 700, 700.
Personally, I'm going to, people are different. Okay. Now, solder melts at around 400 and some degrees, I believe, Fahrenheit.
I think I wrote 360 on the spool of solder that I have.
Okay. So let's say 400. If you have an iron set for just above the heat of the melting temperature, it's going to take a while for that heat to get there and melt.
And it's
the solder.
barely going to melt.
And it's barely going to melt. So some people like 600. I prefer 700 degrees. I set my iron at 700. I know it's going to be almost twice as hot as it necessary. And my motto is you get in, you get it done, and get the heck out of there just as fast as you can. Okay.
I liken it to winter in Maine, right? The snow will melt at 33. It melts a heck of a lot faster at 60.
That's correct. Okay. So there's a 121 in the last capacitor. Whoops, not the last capacitor because there's one more. And this is a 391 right there. 391.
First,
Okay.
I got mine set at 370 Celsius, which is I guess
Okay.
680 degrees or something like that.
Yeah. Okay.
Yeah,
So that's
yeah.
pretty close. Okay. So again, that's what I mean. I have a digital scale right here, and I got it at 692 right now. But that's just a travel. That's just a travel ding on my knob. And you know, I got a digital display on my meter, so I can just crank it to whatever I want. Now, in this case, on the resistors, now I'll tell you two things. I used to go buy these, you know, a strip of anti-static foam, and I would take and I'd say, okay, this is a 4.7K, and I'd stick it in there and I'd write 4.7K. But you know, a lot of times you don't have one of these things. So what I do now is, since all the resistors in this kit are all bent at 0.4 inches, I will take my little lead bender and I will bend them at 0.4 inches. So I'll pre-bend them and get them ready to put in the kit. Put them in the 0.4 slot right there. Bend the two leads down. And now when I put them down on the piece of paper, they don't go anywhere. Okay, so I'll just bend all these all at one time.
So can you show that lead bender a little bit up
Okay.
close? I think
Lead bender, and it's got little slots. This is where you put the resistor, right in the slot. Okay, and each one is 0.4 inches, 0.5, 0.6, 0.7, all the way down. I've hardly ever used this kind of thing. Usually I'm just down here at the 0.4, 0.5, and most of my kits I try to use 0.4 in when I do a layout.
Can you do that without your hands in the way?
Oh, well, let's see. If I do
Can you do that without using your hands?
And whoa, something like that.
It just gets nice sharp bends on it.
Yeah, you just, you know, and they all are at 0.4 inches. Okay.
You could probably 3D print one of those.
I do have one.
Jameco sells them or something.
Yeah, I bought this from Jameco.
Yeah. Okay.
I think it's like $5 at Jameco.
So just make sure, just order 10 of them, and you'll hit the $50 for free shipping kind of thing.
Yeah. Actually, I have another one that's been 3D printed for my squares.
Is that the little white one?
Yes.
Yeah. Okay. Yeah,
I have,
that, yeah.
But it's not. It doesn't really bend the leads at the 0.4. It bends the leads out for a different height.
Oh. Okay.
But I have another lead bender that I use, but it's I send them out when people buy a batch of squares or pads. Yep. And I don't have one with me because
I don't want to get you too distracted.
Okay. So now I got these resistors all bent, so I can pick them out, and I'm looking at the bill of materials. I'm not looking at the bill of materials. I mean, I know the bill of materials. So there is a 56. There's a 100. There's a
oh, there we go. Now it's focused.
There's a 1K. There's a 4.7K. There's an 8.2K right there. There's that's a 220. So I slide those all to one. And there's a 47K. So I can write them down. Bill of materials. That's 56.
56. 100.
Okay. There's a 100.
220.
There's a 220.
1K.
1K.
4.7K.
4.7K. There's a red.
8.2K.
8.2K.
47K.
47K. Okay. So we're all done. We've sorted everything. So I can sort of set that off to one side. Let me get my and stuff won't roll around very much. I didn't do the chokes right now, but I will. I bring my circuit board in here. I don't know how many people use any kind of a board holding device. I talked about it in the last video on Sunday, whatever in the heck day that was. Sunday. I happen to like my little board holders.
Unfortunately, I don't possess a tuna can for Rex to use.
Yeah, I forgot no, that's the other thing. The last time I showed that you can actually put the board on a tuna fish can and hold it when you're soldering. It's very handy. And I left it at home, and I said, oh. Steven's got some tuna cans. No, he doesn't have any tuna cans floating around, so I have nothing here. So I have to use these or nothing. So here's my solution to holding a board is the fact that I can put parts in it and I can turn it upside down like that and I can spin it around and I don't have to do any kind of weird stuff and I can solder way down on the bottom of the bench. I like that. So that's how I build a kit. Now, is anybody got those big tall things? I don't like to build up here because when I'm soldering, so here's where I'm soldering right here on this board. Okay. And if you see my overhead.
Oh, be careful when you move around. You bounce the camera.
I'm sort of going this way. Oops. Okay. Yeah. I'm going this way because I want to show you that my palm is, or wrist or side of it, whatever you want to call it, is sitting on the bench and I can easily get in on this board. So I'm not holding my hand up in the air and that's tiring. So especially when you're building something that's got a lot of stuff on it. So I like to have my hand resting on the bench when I'm soldering. And
do that again. We'll do it in the overhead shot. Yeah, there you go.
Okay. But again, my hand is resting right on the bench. If that was a holder up here, I'd have to have my elbows on the bench and I'd be holding this thing up way up in the air. I don't like that. So when you're building a kit, my personal technique is I always start with the stuff that's lowest on the board. Solder, resistors, chokes, diodes. Those lay down on the board typically if they're not hairpin style. So I put those on because you want to build up the height so that when you're soldering, you don't have tall stuff getting in the way of short stuff. So it doesn't make any difference. What I do is there's two ways to do it. You can pick up a part and find out where it goes, which takes more time than finding something and saying, okay, something I know is going to be one of my first things, which I forgot to do, because I just picked up, picked the first component on the list was a diode, the 5818. And of course, I hadn't bent that yet. So I'm going to bend that now. So the first thing I saw in here was the 5818. So I go to my sheet, get the 5818 and put it down, take note of the orientation of the diode, slide it into the board. I'm holding it down with my finger, tip it over and spread the leads just a little bit. You don't have to lay them down the board. You're just going to spread it just a little bit. So now that thing doesn't fall out.
It won't let me post a link to the chat to the Jameco part. So I showed
it. In my tool talk.
Yeah.
Yeah, there it is right there.
It won't let me post a link to it.
Yeah.
So I posted the Jameco part number.
Okay.
Hopefully that's good enough. $5.95.
$5.95. Yeah. I got a slight deal because I bought a whole bunch of them for my buildathons and stuff. I think I bought about 25 of them.
93 in stock.
Yeah. Yeah. I tried to get someone to 3D print them for me, but it was a little bit just too crazy. Anyway, so now I can put that one part in there, turn it over and solder it, clip the leads, and then continue on. And again, it's not that I want to be a speed demon, but I want to be efficient. I mean, I don't want to waste my time. So what I'm going to do is I'm going to pick up 3 or 4 parts around the board in different areas, and then do everything as a group of 4 or 5 or something. So I'm going to just pick a part over here. There's a 4.7K. And since I got it marked, I can just go to my sheet, pick it up.
Try to keep that on the camera.
Okay. And put it in the 4.7K spot. Come on. Get in there. You know, set it down the board nice and neat. Turn it over. Okay, so there's a 4.7. Now I'm going to pick something a little bit further away so it's not right on top of it. And I'll pick this 8.2K, which is right here. So I can pick the 8.2K, put it in there. Okay, set it down. Okay, there's another one. And let's pick another one. This is a 56. So 56.
Silver band negative on 5818.
Yeah. The silver band, if you look, there's a little
diode. Yeah.
there's a little bar on on the marking of the diode. That's where the band is.
Yep.
Okay. So I've got one.
And you'll see that on the board too.
Yeah, you'll see it on the board.
Yep.
Okay. So now I got 1, 2, 3. I got 4 parts in there. Okay, that's enough for now. So I can just flip it over and get my iron. I'm gonna clean the tip with my scrunchie.
Be careful of the wiggling.
Oh yeah, I gotta watch.
We got some comments about the thumping.
Yeah, we got thumping and wiggling of the camera. So I'm gonna clean this tip.
Let's see if I can move that back a little bit to get a better angle.
I got some tip cleaner. I'm gonna just clean this once while I start this whole process. And
the close-up on this is hard. I was trying to teach some folks just a week or so ago who have never soldered before, and trying to, get the close-up even in real life is hard without them burning their forehead trying to look at what's going on.
Yes.
So.
Okay, so I got myself a little length of solder, and again, you got a little dab on the end of my iron so that I can put that on the pad and the component lead, and then once I let it heat a little bit, I can see it actually sort of wick a little bit, and I can just add a little bit, and that's it. And she's done.
And Charlie has one of those little flip over things. Looks like he's using. He's got one that clamps on either side, and you can sort of spin infinitely around.
Yeah, I don't like it.
I've used them. I've used the things.
Well, the problem is now, see, I want to get over here, and so I can just move this thing, rotate it around, and I can get exactly the right angle for getting that thing in there.
It's all your preference. I've tried to use one of those things that looks like an octopus.
Yeah,
like an octopus of alligator clips. It's like it would go well with tuna fish, I imagine, but it's at the wrong height for me, I think.
Well, if you look at the video I made, it's on my brass set page. I've been soldering stuff since 1963.
Yeah.
Okay. I mean, that's a long time. And over the years, as a professional engineer, I've had all kinds of stuff. And I've got a whole plethora of board holders and vacuum vices and everything under my table just collecting dust because I just don't use them anymore. They're not.
So it's kind of, whatever works for you.
Yeah.
Right.
Yeah. So again, I can just twist this around and get exactly where I want it to be.
So the brass set is under miscellaneous stuff?
It's under homebrew tools.
Homebrew tools.
Okay. Oops, I missed one over here.
Homebrew stuff.
Homebrew stuff. Brass set.
Yep.
Okay. 1, 2, 3, 4, 5, 6, 7, 8. 8 leads. That's 8 cuts.
Oh, yeah.
So now I've got 4 components laid down, and I'm going to cut the leads off. And that you put your finger on the lead on the bottom, and when you cut it, so it just falls and doesn't go shooting off into the never land. You don't want that to happen, especially if you're in a Buildathon where someone's sitting right next to you. They could get one of these things in their eye.
Or if you're at Steve's house and he walks around in his stocking
feet. Yeah. Or my house, I walk around in stocking feet. I don't want to get speared in the bottom of my foot with a component lead.
Yeah. Not as bad as a toothpick, but it still isn't pleasant.
Yeah. In our house, we had a bulletin board at the top of the stairs where all the bedrooms were. And inevitably, when the thumbtacks fall out of the bulletin board, apparently I must have been the only one reading the bulletin board because I'm the only one who ever discovered all the thumbtacks that fell off.
So save your clippings, right?
So put them in a pile.
Pretty good 0 ohm resistors.
You're going to need them later on, maybe. Okay. So now I can go and pick another. There's a 47K. Now again, don't have to hunt at all. I've done that sort once, and so I can just go right to the part I want, put it in, bend the leads, and let's see. The next one is 100 ohms. There we go, 100 ohms. We'll put that in there. I don't worry about whether or not the colors all line up in a certain way because I can read the color code backwards or forwards. I don't need to worry about getting it in the right thing. So,
oh, Charlie has a different set of clippers. They clip from the front as opposed to from the side. Now, those are like the industrial things. They look like, the padlock cutter things, but smaller. They're like the front clippers instead of side clippers.
There's a 220.
Those would work pretty good. Keep stuff from flying around.
And the last resistor is a 1K. So I know where that one goes right there. Now, I designed this circuit, this board back in 2016 when it was the 40th anniversary of the Tuna Tin. So
Bring it towards me a little bit.
Okay.
There you go.
All right. So there are all the resistors now. Okay. So I'm going to polish those off. And so I will just clean my iron just by dipping it in the shavings.
It certainly has a nice.
When I dip it into the shavings, it wipes all the solder off. So that's when you always add a little bit of a bead to the bottom of the iron so that you can get good heat transfer. If you're watching, you can actually see when that heat, the solder starts to flow onto the lead. And then you just add just a little bit more. You don't have to put a ton of solder on these things. More solder is not better.
Well, Eric Gunter says he has a set of 3 vintage brass sets. They've gone dark and green. Why would you want to clean the patina from them?
Yeah,
he wants to clean them to get them like new. That's patina, man.
Yeah. They must have been in an environment that had some moisture in it.
Maybe you've got some of that Brasso polish around.
Yeah, Brasso works.
Yeah,
Brasso works good. There's another thing called Neverdol.
Oh, wait, I got an idea. You could buy another set, and they would come clean.
No, you can't buy brass ones anymore
because I can't. Doing brass ones.
No, my machinist friend who gave me a good price on them retired.
Yeah.
So I farmed them out to another guy, and he comes back and he wants to sell them to me machined for like $10 a piece.
Oh wow!
Not a set.
Yeah, brass
each one.
Brass is not cheap anymore. What are they? Half-inch?
Yeah, they're half-inch. They're half-inch cubes with a slot that's 0.62 and a threaded hole for the.
Yeah, brass is not cheap anymore.
Well, it's also not the best thing in machining. You can make them out of aluminum. Okay, so there's our neat little pile of parts, and there's all the resistors and the diode. So now I didn't do these chokes, so I'll do the chokes next. Now, here are 2 chokes that are taped together because they came on a reel.
You're a little off.
I'm trying to find it.
Yep.
Okay, those 2, if you look on the bill of materials, there's only one value that is got 2 of them, and that's the 1 micro Henry.
Yep.
See it? There's quantity of 2, black, brown, gold. And if I look at it and I say brown, black, gold, silver. Okay.
And if you read it the other way, then
if I read it the other way, it says black, brown, gold, silver. All right. So I'm going to cut those 2 off. Again, I'm holding the leads. Okay. I'm holding those flags there, and I'm going to cut them off so I can just put them in the pile. Don't want them to go flying. I'm cutting them one at a time. Okay, then I'm going to put them in my lead bender. I'm going to bend them. These don't quite fit in the holes as well as the resistor do because of that waspy body, but they will rest up there. Okay, so now I got those in there, so I can put them at the 1 micro Henry location. And the other one goes on the other side. Okay, and we got this one here is that's a red, black. That's a 22. Okay, so I go and the 22 happens to be right here in the oscillator, between the oscillator and the final. Is everybody keeping up with me?
Yep.
Anybody?
Yeah, if anybody thinks we should slow down or something, please
Yeah.
throw a thing in the comments there.
I'm not going fast. I'm trying to just go along. And
John's using a resistor capacitor tester to double check parts before going on the board. I certainly do that with capacitors because those numbers are like faded and Yeah.
Well, that's why the magnifier helps.
Yeah.
Okay, so now we got a 10 microhenry choke, which goes over here.
Of course, you know, I've always got something that calls for, you know, like a 4 meg ohm resistor, and I have a 3.7. So yeah.
Okay, so that is all our chokes. So I'll put that down. I'll do a little swipe in my iron. Am I good? Okay. Little bead.
And yeah, the colors are not as good as not as vibrant as they used to be.
Yeah.
Everything almost looks like brown and black. Maybe it's,
Especially if you're buying.
I'm going to blame it on the color printing, not my eyes.
Well, I actually I think if the part is a really cheesy Chinese part, you're going to see the colors are really crappy. Some things like chokes and stuff, they might be a little bit better.
Well, and the parts with leads on them are getting harder and harder to get.
Well, that's the other problem, you know, through hole parts. A lot of times when I'm doing a kit and trying to do parts procurement, I really got to search to find some of these parts. I've had to go crazy lengths to get some parts, and I've had to redesign kits because parts were not available anymore. Pocket pile is one that I had a 14.318 half size oscillator can. Can't get them anymore. Used to be able to buy them practically everywhere because they were on all monitor boards, but not anymore. So I had to redesign that kit and eliminate that part. I got a better kit now, but I mean, I just had to go. You know, I probably got 50 boards that no longer
Worth anything.
Yeah. So I'm threatening to make a little bench with a whole back wall. It's just nothing but dead circuit boards. Because I got hundreds and hundreds of dead circuit boards. Okay, so we've got all the resistors, all the chokes, diode. So now we can go after something like the capacitors. So I guess I'll just do the same thing. In this case, I might just take the whole 0.1s and get them out of the way. Okay, I'll cut them off the sheet.
And the Digital Rancher has joined us.
The Digital Rancher?
Yep, I'm not sure who the Digital Rancher is, but they have arrived. Hello. Let's see. We got Digital Rancher, John, Eric Gunter, Janice Emery, Earl Stratman, Roger McKeon, not sure.
Okay, so I'm going to just, now that I got 6 of these, I'm just going to find the spots for them. They're all over the board, so it won't be hard to find them. Same thing.
Camera.
Same thing. I'll find a slot.
You're still a little off the close-up camera.
Oh, this way. Okay. All right, there we go. So here's another one over here, 0.1. Okay. And bend that over.
And I think we went through this before. These, other than the diode so far, doesn't matter what orientation.
No, the capacitors, I mean, electrolytics, yes, there's a polarity marking on them, but these monolithics, they are not polarity sensitive. So you can go one way or the other. It doesn't make any difference. That's why you don't see any pluses and minuses on the circuit board where these caps are.
So the 1N, what is it? The 1N5818 is polar. There is polarity, and the line goes where the plus is, right?
And there's also a line on the board, right?
There's a line on the board in the outline of the diode. Yeah, quick, give me a board.
Yep, have another board.
Have another board. Let's see. So here's the. Let's see. Yep. I'm trying to. Whoops! I got to go this way. There it is. Okay. So you see, right there. Right there. See the little line?
Yep. Well, I put it in right before I even looked at the line. So we're good.
50% chance.
50% chance of getting it right. So hey, you're the winner tonight. So I got to find 2 more 0.1s. There's a 0.1 up here.
That shows up on the bill of materials board too. So you can see it there on the bill of materials. Well, you can't. I can't put an arrow there, but
Yeah, yeah.
it's right underneath J3 and next to the big plus.
Yeah. Okay, so I've got 6 of these 0.1 capacitors on the board, and I can still got room to put a couple more without getting all convoluted. So I see a 390, so I'm gonna go pick up the 390 one. Oops, it just moved on me.
And thank you, Roger, for the name correction.
That's the 100. Okay, there's the 390. 390.
And, let's see. Doug is looking for information on the brass set. That is on Rex's site.
Yeah, they are actually now
under homebrew stuff,
homebrew supplies.
which is right here.
Now they're 3D printed.
So they're not brass anymore.
They're not brass.
They're 3D printed set.
Yeah, right there. A brass set.
Yep.
Okay.
Ah, you need to fix the other picture because the other picture still shows them as brass.
Yeah,
Until we get new brass.
I don't have a. Yeah, I call them the X brass set. I don't know if most people kind of know that I used to be a toy designer, so I like to have funny names on my stuff. I need a 220. Well, let's go to this 121 here. 120 will go right there. Okay, so that's enough capacitors. So I do have, as you can see on the close-up, I've got a sea of capacitor leads. And that's why I like this guy, these brass sets. Because when I'm soldering, I'm going to go in, I got a clear shot for this guy right here. Okay, and I can use the back side of my iron to do the other guy. Okay, I can do the same thing over here for this guy. And the front side over here. Now I can swivel this right around. And I can do the same thing over on this guy. Keeping my hand in a very nice, comfortable spot. And I can do this guy right here.
Apparently you can't post links or even things that look like links. So you'll just have to go with qrpme.com. Unless they bleep that out. That might get bleeped out. You never know.
So let's see. Where's the next one? Over here.
No, it's an electric iron.
So what we'll do is get you set up to where you can post links.
Okay.
Actually, or else you can put it in chat or something. You have to be a moderator in order to post links.
Yeah. Okay.
Okay. New stuff that we're learning. That's okay.
Thanks, Charlie.
Yep.
You can just go to the homebrew.
Or, sorry, I should say thanks, Red, right? Yeah. I think get people's names right. I only have about 50 names to get straight right now, and I have to do it within the next week.
Oh, new classes.
Yeah. A little bit. Nope, other way. Yeah, there you go. Perfect.
I'm mirrored on my monitor here, so I'm always going around. Call me wrong way, Corrigan.
Yeah, I need like big arrows to go that way. No, that one's somebody asked if it was a butane iron. No, that one's an electric one. I don't think you brought your butane.
I didn't even bring my butane one.
Actually, I think they might be asking about what I have going on. I have.
Oh, okay.
Let me zoom out here. So I'm putting flux.
Oh, okay.
On my stuff. So you don't have to. It's just kind of some people. It's just a preference thing. But I think this may be what they were looking at. I don't know. Maybe not.
Could be.
Okay, so I'm now. I picked up my board and I'm looking all over to make sure I've got every one of my leads are paired and soldered. So I can now pick up my thing and I can clip. I mean, I'm using my hand to cover these things, so I can't not hide the the clipping part. See, I can find that right there, and then there's where I'm going to clip, and I'm going to put my finger right over the top of the lead, and yeah, I'm going
Don't
to
clip the solder off.
yeah, just you slide right down the lead to where the solder is, and you cut it off, and by doing a batch of 3 or 4 or 5 parts, I mean it's just so much more efficient to build a kit than putting one part down, soldering it, cutting it, bending it, solder, cut, bend, solder, cut, turn over board, turn over back again. It's just so there we are, looking good, and we don't have very many parts left here, so I can go and pick up. I'm working over here in the filter area, and I can see I got a 220, which is still sitting on the carrier, so I'm going to cut those off
the paper. Yep, right there. Right
okay
there. That's the sweet spot, right on the edge of the paper.
Okay, so here are 2 220s. Okay.
Down a little bit too, right on the corner of the paper. Keep going down.
Right there. Okay. All right. So here's a 220, which goes. Where does this 220 go? Right here.
So yeah, he was looking at. Must be Rex. I'm not sure whose iron. Rex's or Reds, but yeah, Rex's is old electric iron.
Mine's a Zytronic super temp soldering station I bought in early 90s. I've had it that long. It's a nice iron. It's worked great for me over the years. Never had a problem with it. Made in Sacramento, California. I called them up the other day. Just chatted.
If you've got the bench space, I tend to like that one there that you've got that has a base to it. Let's see if I can get that on the camera. It's got a base to it, so it's not just an iron by itself.
Right here.
Yeah, hang on, let me do that. So it's got a base to it. Sorry for all the wiggling.
That's okay. Oh well, I'm not looking at the wiggling. Yeah, and I got a dial here. I can just dial up the temperature. I can digital readout. I can do a set temperature, and I got it set for 698. Yeah. Go back to read temperature, and it's got a little light that blinks when the heater comes on. Heats up fast. Nice iron. I really like it. And as I say, I've got I think 2 digitals and maybe 3 analogs of the same vintage.
Yeah.
I used to have a lot of soldering capability, but not anymore. What I just picked up. I just picked up the 680. I forgot which capacitor I had in my hands. I had to go back and look at it again. After that, sword joined into the soldering arena. 56 picofarad is over here.
Sorry, I'm trying to get that close-up camera set back into position for you here.
And the last of these is the 100 down here in the oscillator section.
Yeah, there we go.
Okay, so I'm gonna and I'll.
Okay, so I have a question.
Yep.
Let me show you. You may or may not be able to see, but let me just show you right here. See right here. I see the place where it says right here 22 microfarad, but there's 3 pins here.
Yep.
Yes.
I don't know where.
I'll put mine in and I'll show you. Here's the 22 microfarad. On this one here, you notice there's a round circle at the bottom.
Yeah. Okay.
And then there's a long one. It all depends on whether or not you've got an axial or a radial 22. Okay. A radial 22 is got 2 leads that are close together, like this one right here. That's a radial. Okay. An axial would have 1 on either end, so it lays down on the board.
Okay. So what you're saying is one of those holes is not used.
Right. So what we're going to use is the middle one and the bottom one, where it says the plus.
So can you hold that up to the close-up camera? Get a little bit closer to that.
Okay, yeah. Let's see. Where am I? Okay.
Yep.
So we're going to use the middle one and the bottom one, and we're going to find out. There's the negative on this capacitor. Okay,
The short lead is negative, so that goes
short
in the
lead.
negative.
So the positive is going to go down in the where it says positive, and the short lead is going to go right at the other side of the circle. Okay, and there it is standing up.
So
okay,
that's because you have a axial.
That's because we have a radial, but
Radial.
I designed this to go either way. And if you look at the bottom side of the board, the top side has got a ground, and the bottom side's got a, and the middle one's got a ground. They're both of them are grounded. Okay, you can see the little grounding spots on the layout.
So
yeah, right there. See that little
right here.
Oh, yeah. See the little
radial lines.
The radial lines coming out. That's ground, and then you look at the middle hole, and they got the same ground.
Can I zoom in on that a little bit? Come on, zoom in.
Probably. There you go.
Yep. Whoa.
Whoa. Okay. All right.
There
yeah.
we
See
go.
those? See the ground radials on the middle hole and the top hole.
Yep. The little lines right around that. Right?
So both of those are on ground.
Yep.
And
that
the
one
bottom
and
one's
this
positive.
one. Yep.
So you can use either.
Of course, I'm using a red arrow to point out on a board
Yeah.
with red traces, but you know, that's the.
Okay, so we've got those in there. So now I'm going to take the 2 transistors, and I'm going to put those in the slots.
That answer your question, Charlie?
Yeah, quite often,
Yep.
I have a circuit board that has multiple layouts for a particular part because some people prefer something or a part's hard to get, and I'll show you that in a minute. So I got the 2 transistors in, and I'm just bending those leads over so they stay put. And now I can solder again. So I don't have quite that many leads on here to solder, but that's good. Get me some more solder. And I'll just go in for that part right there. Now I use a relatively you can see my iron is pretty pointy. I use a really fine tip. Uh-oh, message coming over.
What?
Oh, okay.
Nope.
I thought I was going to get another written message.
Stage directions.
Doing something wrong by the stage director. Okay, now see, I'm having a hard time getting that guy, so I can spin this all the way around and come in from the other side. Nice and easy. Okay, this guy is, that's good. This guy is good. I'm going to swing this around so I can come in from this side. Okay, and one guy right here. You'll notice that when you're soldering, the pads that are connected to ground, it takes a little bit longer for them to heat up because those ground radials, which is why I've got radials there, because if that was solid on the ground plane, it would be sucking heat away from the iron big time. But with those little radials there, it slows it down considerably. But you still see that it takes longer for a ground connection to
get there.
To wick.
Yep.
And you just have to wait for it. Now, if you had your iron set at like 450 or 500 degrees, you'd have to wait a lot longer.
Yeah. I know some of them might just go pull out the old electric one that I used for cars. I'm like, okay, there's way too much mass here.
Yeah. Yeah.
Like
well, one of these days, I got
those PL209 connectors for antennas.
Yeah,
just suck heat like crazy.
Well, that's where a nice butane iron really works well on the on those heavy duty connectors.
Yeah.
Crank that up to maximum heat, and they really work nicely. Okay, so I missed one transistor here. Okay, I think I got 1, 2, 1, 2, 1, 2, 3, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 3. I think I got them all. So I'm gonna cut these guys off.
So I have until Sunday to build my kit.
You have until Sunday. Well, I just saw your kit collection.
I have more. The built ones are actually, well, I don't have them in tuna cans.
Yeah, we went searching in his
I have peas.
yeah, he didn't have a tuna can or a Dole's pineapple can to be found anywhere. So, okay, so there are all my, and look, my sheet is empty. There's nothing on there anymore.
Where's the dang 120 puff?
What's that?
The 120 puff, where's that at?
That is over here in the
Oh, I see it.
right next to the receiver.
It was kind of hiding behind that.
Yep.
Yeah.
Right underneath J1.
Yep. J1. Okay. How's everybody doing? Are they staying with me?
We'll pause for a little bit and see
Yeah.
if people comment, see where they are in their build. Looks like one fellow, at least from the Canadian Rockies, has missed a bunch, but supper got in the way. We didn't stop for supper.
What? Canadian Rockies? That must be Eric?
BE6JTW.
That's Jesse.
Jesse.
Oh, okay. All right. So,
People eating dinner. I don't know.
yeah, I was with dinner. It's 8 o'clock. We haven't dinner. I had a little thing of Pringles. That's it. I don't dare have dinner before I have one of these things because I might have to do something. Okay. So now, so here are all my little clip leads. So I'm going to find a couple of the longest ones. Okay. And where it cut off with, there might be a little bit solder on there. I'm just going to cut it off a little bit more so it's fresh. So it's just got a lead. And I'm going to take my pair of pliers and make a nice 90 degrees square connection. And I'm going to put it over here where it says ground. And that's so that if you happen to want to debug this thing or put a frequency counter to it or something, you got a nice little spot right there to put your ground clip.
So like on Sunday when we hook the scope up to look at stuff,
yeah,
you've
so we're
got
gonna
somewhere
on
to
Sunday
clip
we're
on.
gonna put a scope to this baby. And we're gonna do some fun things. We're gonna look at the signal. We're gonna see how much we can crank it and get more signal out of it, and possibly, well, not possibly, I'm gonna show you how you can move it anywhere you want. Because
so got one person here missed a part, got two 120 PF and no 100 PF.
Really?
How critical is it I use the 120 in place of the 100? Oh,
well,
Doug.
yeah, you can use the 120 down at the 100 puff.
Or the
down in the oscillator section.
Yeah. So
yeah, that's only, I mean, that's 20% off, but that probably would work. I mean, it will work because
where's the other one? So you got
one's in the filter at J1. J1.
I see that one.
And one's down here at the oscillator, the output of the first stage oscillator.
Okay. Okay.
Now, at 120,
what is the schematic? I don't think it might make a difference there.
look at it. It makes a slight difference there.
Yeah.
Okay. Because that particular capacitor is in a voltage divider, RF voltage divider, to feed the signal level. You see it down here at C4. See it C4 down bottom?
C7. Oh, yeah, right.
Okay.
Right there. Okay, yeah.
Okay. That capacitor and that inductor form an RF voltage divider to feed the signal out of the oscillator over to the final.
Yeah.
And all it's going to do is change the level a little bit. Okay.
Yeah, okay.
Now, if you want to move this thing to other frequencies or other bands, then you change C4. Okay. And I had a table.
Trying to get that on the screen for folks. There we go.
There it is. Okay. See the
So then
C4?
C4
Yeah,
down
right
here,
there.
yeah.
Okay. So at 80 meters, I believe that value would be 220.
Okay.
At 40 meters, it's 100.
Yeah.
At 30 meters, I believe it's
So this might make
68, and
Yeah.
at 20 meters, it's 47.
So if he puts a 120 in there, well, it
It's-
depends on the tolerance of the cap too, right?
Well, that's true. Okay. These are actually 5% caps.
Okay. So
Okay. So that would be
Yeah.
anywhere from a 95 to a 105.
Yep.
Okay. So 120 is a little bit high, but all that means is that at 40 meters is just you see that value 4.0.
right,
Okay.
right up here.
That's
yep.
what an RF probe would read. That's how big the signal is coming out of that oscillator.
Yeah.
Well, if you have 120 picofarad there, it's just going to be a little bit less. Okay. And so it's going to end up going through the 220 at C6 and then end up over at the final. And you're just going to have I think you're going to have a little less signal there. So it'll
Less
be
than
just,
the 3.8.
yeah.
Yeah.
So it'll be just a little bit less strong. So it won't be putting out quite as much power.
Yep.
Okay. That's all. No big deal. And in fact, this leads me to a certain thing. I've actually asked designers of certain well-known kits as to why they chose a particular value, and they said it was in my junk box.
Yeah, that's the one I had. I designed around.
I've been kidding something for years, thinking I got to go get this particular part, and it was hard to find. Okay,
Yeah.
and why this? I mean, there's several different versions of the kit, and this particular version, one band had a different value. And I said, why?
Yeah.
It's in my junk box.
Yeah. Why'd you use a 4.6 ohm resistor? I don't have a 4.6 ohm
Now
resistor.
here is a case where we need three. We need a 3-pin.
A little more to the corner of the paper.
Okay, right there.
Look at the paper.
Okay,
corner of the
let's see if we can
Yeah,
do
there-
this. Okay, there we go. Over here at the crystal, I gotta find a pointer. At this crystal, we've got a 3-pin socket. And of course, the crystal has only got 2 leads on it. But if you take, this is where my handy dandy kiloton cutters, I mean, you can cut this with a pair of flush cutters or something, but I like a really nice, clean cut. So I use my guillotine cutter to slice that in half. Okay, and then what I can do is I can mount that to my crystal.
And one,
Okay.
you don't have to deal with all the heat of the. Well, I guess. You still
Okay,
put the
and then I
crystal
can
in
put that, there and hold it with my finger. Okay. This is where you need about 6 hands sometimes. Well, okay. Here's a hand right here. Here's my roll of solder. I'll just put up into my patented, I should call this my patented Cobra stance right there. Okay. And let me put this back in.
Drop the crystal.
I just dropped the crystal. Okay. I was switching hands. Okay. So what I can do is now, see, I can get right in there with the solder, and I'll get my iron, clean it, a little dab of Douya. Okay. Now go in there. Okay. Now, that's all I did is I soldered that 1 pin. Now you look and you see, okay, oops, where am I? There I am. See, my crystal now can stay put. Okay. So now that I've got it in there and I don't have to worry about more solder, now I can just use my finger to wiggle this and make it nice and square. So the crystal is standing straight up. I'm only working with that 1 pin. Okay. I need a little bit more this way.
There you go.
There it is. That's a nice, see my nice crystal sitting nice and proud, nice and straight up and down. So now I can put it down and I can do the other two pads.
And the middle pad, the middle pin doesn't really even connect to anything.
The
so
middle
it's just
pin,
there
the
for-
middle pin is grounded. Okay. And the reason for that is the fact that
Are you going to ground it?
Huh?
You're going to ground the case?
you can take and ground the case. Now in this case, the case is sitting a little bit on the high side.
Move the solder out of the way.
Okay. Yeah, we don't need that anymore. Okay. So here's the other thing is if you plug this crystal in you got these big, nice, tall leads of a 1/2 inch. Okay. And remember, we got RF. So every extra millimeter of length of anything acts as a little antenna. So the idea is the fact that you might want just to be perfectly proper. You should take and cut that crystal leads off to a short value. So when you plug it in, that crystal sits pretty damn short to the board.
So,
Okay.
Rich asked, or I'm sorry, Rich asks, states, some you shortened prior to insertion. Most you did not. Did you cut any leads shorter before you stuck them in? I didn't think so.
Nope.
Some come with shorter leads to identify the polarity, like the,
Well, sometimes I cut them off the tape. Okay.
yeah, just to get them free of the
just to
tape.
get them free of the tape. But I
So
didn't.
show the tape. Yeah, so that you didn't have to peel them out of the tape.
No.
You just cut 'em
I just
off.
cut them off because I
Yeah.
know they're all long.
So it wasn't any identification. There was no
No.
magic behind cutting
No.
them short. It's just like,
No.
okay, how do I rip
See,
them off of this tape?
They were actually, see, you look at the leads are actually very long on the tape, but
Yeah.
I didn't need anywhere near that.
Yeah.
Okay. And I don't have any to show you. Yeah. Hand me a tape.
Yep. Yeah, I was going to show you. I was going to hand you a board too because the
No.
diode question came
Yeah,
up again.
okay.
Don't cut those off the tape. I'll get them
I'm
on
not.
stuff.
Okay. But see, I know, see, there's a 1/2 inch there. I know that I didn't need anywhere near those long. So I just cut them right along the tape.
Rather than
Okay.
just peeling them off.
Oh yeah. No.
Because, yeah.
Peel them off. You get gum all over. You don't want any of that glue or anything that's on the tape. So I cut them clean.
Yeah.
And in fact, when I'm doing kits and building them in a batch mode, I run this thing through a machine that I have. I paid, I think it's $1,500 for this stupid thing. And this tape runs in there and it's got a rotary cutter that cuts them off right at the lead.
Yeah.
Okay. So if I need a whole bunch of those, then I gotta run them through the machine. But that's all. I just cut them off the tape.
Then the other question was over here on the diode again.
Yep.
And there's right there on the circuit board, you'll be able to see there's a little extra line that shows.
That's the orientation line of the diode.
So the diode will have a white band on one side of it and not on the other side.
Correct.
You can show the one on your circuit board.
Oh,
It's
let's see. Okay, there. We're getting there.
Yeah. So it's got,
Okay.
or actually it's a silver band on that one.
Yeah.
Next to the electrolytic. Yeah.
Right there. You can see that. See the silver band right there?
And it matches up with the extra
It
line. that
matches up
shows
with the
on
extra
circuit,
line.
which is also the side that's listed as positive, right?
And that's the positive.
Yeah.
Yeah. If you put it in backwards, that's okay. It just, nothing will work.
Yeah.
Because no voltage will get through the circuit. Okay. So we have put all the little components on there. Now we just got a couple of the big ones. And so I'm not going to use these. Well, I don't know. Let's see. This one here will fit in there, but
And you already put the transistors in?
Yeah.
What are they,
Yeah.
fall asleep?
I snuck them in there when I was
I was
doing
going to say,
the,
I dozed off. Those have to go in the right way too.
yes.
And
And you'll
those-
see there's a little picture in there. It's like a half round.
You can show it on the
Yeah,
board.
I'll show it. Okay.
Flip the board up towards the camera. There
Yeah,
you go.
okay.
Yeah, perfect.
On a transistor, there's a half round. Okay. And there's a flat face. And you look at the transistor, which I can't show you because I've soldered them
Yeah,
in.
but
Okay.
there's a flat side to
Yeah.
yeah.
Here we go. See, there's a flat side here, and then there's a half round.
Yeah.
Okay.
Yeah.
That's what the silk screens, that's what the silk screen tells you is exactly how to install the part.
So yeah, and right here you can see the flat side of where
The flat
that
side.
transistor
Look over
is.
the other side on the final. That's
And
a
then
little
over
the
here,
more
here's the
pronounced,
flat
There's
side.
the flat side.
And this is the curved
Yeah.
side, so you
And
can
if
tell
this-
which way it goes.
If there's an electrolytic capacitor, it'll show you the plus sign. Okay, right there. There's the
That's
plus
right.
sign.
There's
There's
the
a
little
diode.
plus
It'll show
sign.
you where the bar is.
And there's the bar.
And that's
and there's
about
an extraneous plus sign. I don't know what is that.
Yeah.
Plus, that's for the diode.
I don't know.
plus
Get that
and-
arrow out of the way.
Yep.
No, that actually is that's 12 volts coming in, and then that's
Ah.
now it's signifying it's just plus.
Okay. Okay.
Then it goes through your key,
Yeah.
and you got the two little.
Oh,
I'm
yeah.
sorry, I'm
You-
looking at the screen. I'm not
Because
looking.
you've got
at the
like
camera.
a little arrow here that shows which way stuff is going.
Right. That's
Yeah.
the actual keyed plus 12 volt,
Yep. Okay.
and that whole line is keyed
Yeah.
with 12.
Okay.
So that's how, and that's why the Tuna Tin 2 circuit, when it's off, when you're not keying it, there's no power to it, so it just is silent. Okay, and the minute you key down, you apply power to everything, and it comes up.
Yeah.
So I'm going to take my little brass set off now.
Pass the other board back.
Oh,
Get that out of the
yeah,
way.
Steve wants his board back. Okay, so now here's the one thing that a couple of builders missed when they put it on there. Again, one of the problems that I have is coming up with RCA connectors, because they're getting harder and harder to find. I had to buy when I first went into the Tuna Tin 2 business back in 2000, and I don't know, I think it was like 2007 or something when I made the first version of the Easy Build. I bought, I think it was 20,000 RCA connectors.
Wow.
No one. I mean, RCA connectors are going out in the way of stereos and all that kind of stuff, but especially these right angle ones with singles. I bought 20,000 of them. I thought it was going to be a lifetime supply, and it wasn't. So I had to go buy more.
Lifetime has lasted longer.
And so now I have to search far and wide to get them. And I think I'm sitting on top of maybe 5,000 red and 5,000 white, but no yellows.
Wow.
I can't find a yellow to save my soul.
Wow.
So one of the things you notice is that these holes on the three RCA connectors are not quite the same. The one in the middle.
Angle that a little bit more towards the camera.
Okay, there we go.
Yep.
Sorry about that. Okay. The one in the one on the outside between the two, that's bigger than the one on the inside. And these connections are just a little bit different from what this connector was. So in the case of the RCAs, I use red to signify the positive, the 12 volts. So what I'm going to do is I'm going to take my second tier cutters, and I'm going to take that back connector, and I'm just going to nip off a little bit of the edge.
I don't think I can really get a close up of
I
it.
can't.
Yeah.
Well,
because you've got it in your hand.
Yeah. Well, hang on a second. As soon as I cut it, I'll show you. Okay.
So a little piece fly off. Yeah.
I just shaved a little bit off one corner. Okay. And now that oh yeah, that should fit in there. Rocking it back and forth, and I can see it. I can see it coming through. Yeah, I'm going to cut a little bit. I'm going to cut a little bit more off of it. Wasn't quite enough.
Carl Jones says he has a nice 7 megahertz output on his.
So I have a question. Another one.
Yeah.
It looks like I have a solder bridge on one of the pads. I don't know if it's going to be okay or if I need to clear that bridge out.
Where is it?
I mean, let me look at it first and find it, and then I'll tell you.
I nipped a little bit more off that thing, and it should go in there much easier. Oh, look at that. Went right in nice and neat. But I also noticed that, yeah, it's sitting okay. All right, so I'm going to take the white one. I'm going to nip a little bit off of both sides of that. I'm going to basically turn it into a little bit of a
okay.
And I'll bring up the schematics, or not the schematic, the board.
So you can show us where you.
Yep.
Okay. So it's there's 3 here together. If I flip it over, it's where the 1K and 8.2K meet the 220 puff. There's like 3 right in there.
Yep. That's fine. That is a common
right here.
That's a common point. They're all shorted together. So you can have that blobbed up nice and neat.
Okay, cool. Phew.
Yeah, you're good. You're good.
I have the arrow in the right spot.
Yes.
Okay.
Yes. Okay, good.
Okay. So now I again took a little bit off of both sides of the white one, and that fits in there nice and neat now. So you don't have to force it. If you force it, you haven't taken enough off the. We're only working on the back one. Okay, the one that's in the back of the connector. So I'm just taking a little bit off that.
All right, so I'm missing a 680 puff. I guess I need to look at my kit, my junk box, and see if I can find one.
You're missing a 680?
Yeah, let me see if I can find one.
I think I got one.
Yeah, we'll teleport it over to you.
Just hand it over, man.
I'm sure there's one inside your computer you could take out.
Okay, so there are my 3 RCA. Went on there without much brute force. Okay, and I'm going to take the stereo jack. Actually, I find on the stereo jack, I like to actually, they are severely kinked, and I like to straighten them up when I put them in.
Okay, so I missed some stuff because I was doing my own thing. So it looks like you're trimming the RCA jacks, huh?
Yes, we're trimming the back connector of that RCA jack. You look at it and it's got like a little notch on it.
Yeah.
You see how it comes out and it flares out and then back in.
Let me grab one and see.
Closer to the
Yeah,
camera.
we're gonna try to go. Yeah. Let me
Oh yeah, I see that. So that's
so it flares out. So we're gonna cut a little bit of that flare off and then make a little bit on the other side, so make it more pointy.
okay.
Okay.
Yep.
Just I'm gonna cut it off and I'll show you. I'll cut this guy off. And I'll cut the flare off a little bit. Come on. Okay.
Just me says his capacitor somehow got inside his RCA jack.
Yeah, a couple.
All right,
There we go.
you can't see it
Let's
that way.
see that. See?
Closer.
Yeah,
Closer.
okay. See how I made that like a spike? You see the back end of that is now.
Well, what do you know? As I'm holding the RCA jack, out pops a 680 puff.
Well, thank you for just me there mentioning that.
Oh
Yes, I should have mentioned that because someone reported that he was missing a 390, and then later on I sent him a 390 and said later on he found it inside his RCA jack. So yeah, I knew that was going to happen.
So you can use all those excess RCA jacks for packing material. Right?
Yeah. Okay, so now there are some serious ground connections here, which is where this is where having a digital iron where I can crank it up to, I'm going to crank the set temperature to 800. And I'm going to wait a second. I'm going to actually add more power. More power.
Sure thing, Scotty.
Yeah. No, I was thinking more of tool time.
Yeah.
More power. Oh, the Binford 1000. It's going to turn into a Binford 7000. But so, I mean, yeah, at 800, these things are soldering very nicely. I got no problem at all with that. The outside one is a ground connection, so you can see the ground rays, and that sucks up a lot of heat. But it's going in there very nicely. And that's where if you had a 25-watt iron or a 30-watt iron, that would be very hard to do. So if you really do like doing circuits, building kits and stuff, I would seriously recommend having a soldering station of some quality. Not one of those real cheapies, but I think I paid about $79 for my Zytronic back then. I think they're about the same price, but it's a nice. And the big thing is, of course, being able to buy new tips, a new handle if you need one, new tips, heaters, just spare parts if it's American made or has a brand name that you can track down. It's much better than buying something that says Zing Pow.
Yeah.
I need to solder my little ground jumpers. Now, see, I'm having trouble because my board's wiggly now because I took my things off. So I gotta push it down, keep it from rocking with one finger, one hand, and I mentioned Sunday that if you had a tuna can, you can actually put it in a tuna can and use that as a holder. But the problem is the minute you start putting connections on it, you can't put it in the can anymore. So it ceases being a convenient holder when you start putting the connectors on. But that's okay. There's only a few more things. And what I do is I plunk my finger down on the board and hold it while I'm soldering these rogue connections. And there's those three. So my RCAs are in, and my stereo socket is in, stereo jack. So I'm down to just a couple more parts. And one of them is this TR switch. So I can put that in there on the top side. I can hold that down with my finger. And again, I'm going to use my patented this is my striking Cobra. And I can use that. That's one hand. There's another hand. There's a third hand. So I don't need to put it in any kind of a weird connector or thing. I can just and again, I solder only on multiple connector items or multiple terminals. I can look at that switch and I can say, ooh, that's not very stable. So I now have a chance to make it fit nice, upright, square, everything else before I hit the other two pins. You don't want to solder them all at once without double checking that it's good.
Eric is saying salmon would be healthier, so you should have a salmon can, not a tuna can.
Well,
I've never seen salmon in a can.
Yeah, but I've never seen a short salmon. But
yeah.
Now here's a case I accidentally bridged the center connector, so I'm going to heat it and strike the board. And my solder bridge went away. I will just double check all three of those connections to make sure I'm good. And there's most of it. We're missing one thing I should have done earlier.
Okay, let me take a look at that real quick. So here's my board. Let me turn it around here. So you have the receiver here on the left. That's white.
Yep.
Then on the middle one is going to be white, and then the right one is going to be red.
The plus 12 is red, just like you would think on wiring. Typically red is power.
Okay.
So it's just help visual. The last two things we need to do is find two more little leads and make tight jumpers.
Can you move the solder out of the way?
Yep, move the solder out of the way. I'm making a tight jumper on the lead, and I'm going to take and I'm going to solder it. I'm going to place it in these where it says tip and ring.
Yeah, that's behind the stereo.
That's behind the stereo jack. Okay. Yeah. Let's see. Right in here is tip and ring. And that just basically takes either the tip or the ring of your stereo jack and uses that as the switch.
Can you hold that up a lot closer? So you're going.
I'm going horizontally across from tip, and I'm going to do both tip and ring. So I normally do that on the Tuna Tin. So either the tip or the ring. What the heck was that?
A big fan going on.
Oh, that's my fan. My solder fan.
Okay. All right. So I got to get another one for the ring, and all that does is sometimes you've got a paddle, a mono paddle that's only got one connect. Now see, look, I'm trying to cut this lead with my
screen.
With my second tier, and I've actually landed right in that damn hole. I got to throw my second tier away and get my first tier back again so I can cut that properly.
So you're connecting.
I'm connecting
these
both
two-
tip and
these
ring.
two things, and then these two things.
Right.
Yep.
You
So
see the little blue line across? You can
yep,
you
the
can
little
do either
black line there. That's what you're connecting.
either or. So what's going to happen is either now if you plug a set if you plug paddles into that, okay, then you can either make it work with the left or the right paddle for tip and ring, or both, either. Okay, I'm just using it either because that's just the way I do it. I plug a set of paddles. I don't care which one I'm using. I'll figure it out, and then I'll just use the dot paddle or the dash. But so I just pull those in and make those jumpers across there, and that's the last of this kit. So I'm going to get a little bit more solder, and I'm going to hold this. Let's see, where are they now? I'm going to hold this down with my finger so the board doesn't wiggle around, and solder those two jumpers in. Cut the leads off. Okay, I can solder I can put my crystal back in. And there is a Tuna Tin 2, all built, ready to test.
Tuna canless.
Huh?
Tuna canless.
Canless. Okay. Now I recommend you can go out and get a can of tuna and eat a tuna fish sandwich, which, you know, you're gonna be eating some mercury and those poor little tunas and stuff. Or you can go out and get some Dole's pineapple, which I love. And I don't have any problem because my daughter's a vegetarian and she can go through 6 cans of pineapple in a matter of a day or two. I think I got 6 cans up there in my pantry.
Don't wiggle the board. Just
I'm sorry. Don't wiggle the board. That's making thumps. So here's your TR switch. So when you're transmitting, you have it over to T, and now the antenna is connected directly to the transmitter. And then when you go over to receive, the antenna shorts over to the receiver and goes to the receiver, and that's it. So you have to go back and forth. That's old school.
Yeah.
Okay. New school, you would have an automatic TR switch or some sort of method to do that. Now, I do have a corresponding kit, which is the Sudden Storm receiver, and I do have a third tuna fish cam, which is an automatic TR switch. So, and that's it. So that should work. Now on Sunday, I'm gonna get this all rigged up with the dummy load and all that kind of jazz.
Did you bring the dummy load back?
I did not.
Okay.
I don't know how much time we got.
Put that back on screen.
How far are we into this whole thing?
9:30. So
9:30. So we've been at it for an hour and a half.
Yep.
Let's see. I have 3 parts left, I think.
it's got 3 parts left.
So there's the switch.
Yep, right there.
And then the I guess the part that goes in for the crystal. There's like a set of 6 pins. Yep. Is that for the crystal?
Yep. You cut that in half, so you get a 3-pin. Okay.
And solder that, and then put the crystal in after. Okay.
Well, what I do.
The crystals. Yeah.
Okay. Go back to my close-up camera first.
Yep.
Okay. Unfortunately, what I do is I plug the crystal into the socket.
Yeah.
And use the crystal as a holder so that I can hold the socket while I'm soldering 1 pin.
But you do cut that 6 long pin header into 3.
Yeah, I cut it in half. So see, this half is already on the board, and here's the other half of it right here.
So you get an extra half.
One of the things you can do is you can use this other half. You can cut it into separate single pins and use it on the final transistor so that you can
blow it.
Yeah, in case you blow that final transistor, you can just pop it out and put another one in.
Okay, and then
all of 10 cents.
Does it matter what way the TR switch goes in?
Nope. No polarity there. Okay. Now this rig puts out the way it's configured. Again, down here we got a 56 ohm resistor in the emitter of the final transistor. That limits how much power is going to come out of this. This will put out about 250, 300 milliwatts.
Yeah.
You can replace this. You can parallel this with a another resistor, okay?
Yeah.
And crank it up.
And crank it. Yeah.
Yeah, you can get almost 600 milliwatts out of a Tuna Tin tube.
How much? What did Hans get out of the transmitter?
Well, he got a lot.
Yeah, I mean, like, if you want to fry it.
If you want to try it, okay.
Red's the others. Yeah.
What is that anyway? Is
I
this
think he's got a solder fume extractor.
a fume extractor?
Oh, sorry.
Okay.
I keep forgetting to mute.
It's okay. Yeah, if
Okay.
you want to seriously overdrive it, you could. But
Yes. I mean, originally that 2222 power contest.
Yeah.
Everybody was thinking. In fact, I was thinking about actually putting I got a heat sink that's actually aluminum, and inside a chamber you can pump cold water into it, so you can cool it.
But you could put a heat sink on that transistor. And
Oh, yeah.
Try to
Oh,
get more power
Yeah.
out of it that way.
If you look at my at other variations of the kit, I mean, you could if you had the socket there, then you could pop that on, put in like a 3866, get a little bit more power. You can put a heat sink on top of that, and you get even more power.
Yeah.
I get roughly at 40 meters. I think I get roughly 2.5 watts out of a 3866.
Yeah.
But that's a slightly different circuit. You're never gonna get that kind of power out of just an oscillator and a final. But we're going to show you that next Sunday. We'll have this rigged up, and I'm going to build a separate one where we're going to vary
bring
the
it down to the corner of the paper.
Bring it down the corner paper. So Sunday, what I'm going to do is I'm going to take this thing. We're going to take one that's built stock, okay, and then we're going to go down and we're going to change these two capacitors, okay, and I'm going to show you how we can put other crystals in here. We can put an 80, we can put a 30 or a 20, and we can get this thing to move on to another band. Now, up here, this low pass filter right here.
We swapped the crystal too, right?
Yeah, we swapped the crystal. Okay.
Yeah.
So if you put in a 30-meter crystal and you
Is
change
it polarity in a crystal?
No.
Sorry, I
No
don't know this. I've not used
Nope.
one.
No.
That's the whole purpose of a Buildathon, to learn these new things. You're busy climbing the summit of something and using an appliance, okay, but now you know, okay. You've actually published something from oh shoot, now I got a senior moment here. I've lost his name. Out of San Francisco, he's flying a rock bite with an amplifier in Hamilton. Hamilton Carter. Hamilton. Yeah, his daughter's name is Hammy. She's just got a license.
Back on the RF probe.
Yeah.
On the probe, which wire goes to center? White and black goes to ground on the RCA jack.
Okay, what was that again?
On the probe, which wire goes to center, comma, white, and black goes to ground on the RCA jack. So on the RF probe, which goes to which? You have your RF probe right there?
Yeah, well, okay, here's the wires that you would have on an RF probe, okay, which I don't have. I could build one real fast.
No.
Okay.
So you made one last.
Yeah, I made one last time.
And you had a black and a white.
Black
wire.
and white, that goes to your meter. That goes to your voltometer. Okay. White goes to the positive, black goes to the negative. Okay. This little wire with the alligator clip, that would clip to your little ground connector that we just, here we go. On this guy right here, we got a little ground connector right there. You'd clip that to your ground, and then you would probe around your circuit.
With the probe. And
with
we'll
the
be
probe.
doing that on Sunday.
We'll be doing that on Sunday.
Okay.
We're gonna use the probe. We're gonna use a dummy load. We're gonna crank this thing up. We're gonna see what kind of power comes out of it. Then we're gonna change the frequency or change the band. Okay.
Davey KU9L says he gets about 300 milliwatts out of his Tuna Tin tube.
The stock one that we built right here. This one.
I don't know if it's this one or not. I assume it is. He's here.
I don't know. I don't know. Davey's bought a whole bunch of things from me.
Well,
Okay.
yeah.
Davey, is that this one here? Is this a stock this one, or is this like an easy build or something else?
Yeah. So.
It all depends on this resistor down here, which is limiting the amount of power this final transistor can output.
Yep.
The closer you run it to ground, the more output power, and the more heat goes in that transistor, the more chance it has to burn up. Okay.
And
R7.
R7.
Okay. R7, C7.
Oops,
Okay.
Hang on. Let me.
If you grounded
it this way, then R7 is down here,
all the way down,
bottom, off the bottom of the screen.
yeah,
that
all the way down, right there.
Here,
See it?
Down
in the
here.
amplifier, right?
Yeah.
Now that limits the amount of current that goes from collector to the emitter on that transistor. Okay, 56 ohms. So you see it
here.
Yeah. Now if you take that and short it to ground,
right here.
Right. If you take that away, then more current can flow in that circuit, which means you get more output power. But more output power and more current
heat
to that transistor means more heat to the transistor. So you don't want to do that without a heat sink. Yeah. If you put a heat sink on that, you can crank up more power.
Until the magic smoke escapes.
Until the magic smoke. And then, of course, if it has that in the whole 3-pin socket, then you can just pop it out and put another one in for 10 cents.
Yep.
So, yeah. So, huh?
Oh. I still have a couple questions.
Okay.
Okay, so
fire away.
One of them is actually, let me switch back cameras here real quick, and I'll show you what they are. Okay, so the first question is there are four holes right here that I'm wondering, are those? Did you talk about those?
Say tip and ring?
Yeah. Did you talk about those?
Yep, we did. We put them in.
Okay. So I'm supposed to have something in there?
Yeah, you're supposed to use some cut off components and
that's
them in
right.
little shorts.
Okay, I'll go back and watch the video on those. Okay, so the other thing is there's right here next to the switch, there's like 3 big holes.
That's if you want to put a bigger switch in.
Okay.
This is a sub miniature switch, which is very hard to find and very expensive.
Yeah. Okay.
But the other 3 holes are for a bigger switch. Okay. If I needed to put a bigger switch in there, you can get bigger switches cheaper. But
so I think I did it then. I just need to do those last things, the pin,
right,
whatever you call.
So yeah, you would connect those right across here horizontally this way. So
now you were probably busy doing some catch-up work, but
I was.
Let me reiterate. That's a stereo key jack, okay? And when you look at a stereo connector, you've got a tip and a ring and a ground. And on let's say, for instance, a set of paddles, tip might be the right paddle, which would be a dot. And ring might be the left paddle, which would be a dash. And some people would prefer to have it only work one way. Okay. So only the dot would work to key. So you'd only do the tip.
So you'd only connect this bottom one.
Yeah, the tip. And in my case, I don't care what I plug in there. I'll figure out which way I want to operate or what have you. So I just connect both of them. But that's okay. That's there for an option for anybody who wants to be really persnickety about which one they actually want to actually key with.
I just do both of them. I can figure out the polarity and stuff
like that. Same here. Okay. So I do it both tip and ring because no matter what you plug in, it's going to work. So it took an hour and a half with a lot of talking and a lot of other stuff. Okay. So it's a very, very easy build. Now you can jazz it up, which is what we're going to talk about on Sunday, and we're going to hopefully everybody will have theirs built by then. They'll catch up, and they can try them. We can show you how you can test the output power, all that kind of stuff, and then we'll talk about if you want to move it someplace else. Because originally, back in the old days when I first started doing Tuna Tins, I kitted them with parts. Go back to the website again and just see if that TT8 Tuna Tin 8 schematic is up. Would you?
While you're doing that, I'm going to zoom in on the tip and ring for Davey.
Yeah,
if I can.
Yeah, I'm trying to. That you're looking for not our schematic. You're looking for
On my website,
yeah.
on the web page, there should be 2 schematics. Did I put the second one schematic up?
No, you didn't.
Ooh, I didn't.
No, we've just got that one schematic.
Oh, okay. Well, I'll get it up there. I'll get the second schematic for the original Tuna Tin that I kitted years ago. When I was kitting them I had 80, 40, 30, and 20 meter versions of the Tuna Tin. But it got rather convoluted trying to keep all those cans up on my shelf. So when I created the easy build, I fixed it at 20 meters. I mean, at 40 meters. Okay. Yeah, we see that.
So those 4 holes right there, right to the right of the black jack is what we're talking about. Those need to be connected.
Short, straight across both sets.
Yep.
Okay, straight across, horizontal. Okay. And that will make the tip will switch power or the ring will switch power, either one.
So across here and then up here across the top 2, back this way.
Yep.
There and there. All right. Hope that helps, Davey.
Yep. So just me asking, why do we have 2 RCA jacks?
Why do we have 2 RCA jacks?
I think it might have been, that was a question from earlier when we were talking about something. One goes to you've got
one
3.
goes to the antenna.
Yep.
One goes to the receiver.
Yep.
Okay. And if you're transmitting, then you put your switch on T for transmit.
Yep. And
the output of the Tuna Tin goes out to the antenna, but it does not go to the receiver. Okay. Because you don't want to blow up the front end of your receiver.
Yep. Okay.
When you stop transmitting and you want to now listen, you turn the switch to R, okay, for receive. And now the antenna goes directly to the receiver.
And then the third red RCA jack is your power.
That's the power.
Yeah. So James wants to know how fast your shipping is because he's apparently going to order something tonight. Maybe.
Well, it depends on what
it depends where you are.
Okay, tell me what you're going to order. And I'll tell you whether or not I got him.
Joseph asked, did you ever put a jumper block there instead? Like header pins that you could just put a jumper over.
Give me back your board. Give me back your board again. Okay. This way. A jumper block where?
You could put like for the tip and ring connections. That way you can just use a jumper.
No. But I just want to say one thing.
You could. What's the spacing on them? Is it like 2.54?
Yeah, you could. I don't know if I spaced them so that they're exactly 0.1 on center, but they might be. I might have. Yeah. It's inconsequential. I mean, generally when you're using a Tuna Tin, you're using a straight key and not a set of paddles anyway. So, it's no big deal. No, give me a close up again.
I don't have a close up.
Oh, you don't have a close up again.
We got the overhead.
Okay, we got the overhead. Okay, give me an overhead shot. Okay, if you look at this power connection, you'll see it's got a really kind of a weird layout.
Flip the board around so it's the same orientation as the schematic. Oh, yeah, there you go. Yeah, okay, perfect.
So now I got to point to it upside down. Okay, so you see that there's these are just footprint holes, but there's the negative and the positive, and then there's 2 little ones right there. You can actually put a 2-pin terminal block in there.
Oh, okay.
Instead of an RCA,
one of those green terminal blocks.
Yeah, a greeny screw terminal block. You can put it in there instead of an RCA.
Yeah.
And feed your wires in directly with screw terminals. But again,
John says he did put a terminal header in, and it spacing works out fine.
Oh.
Just me said he was. Wait, make sure I'm getting these in the right order.
Just me. That's Newsom, isn't it? Just me.
Might be. He put a jumper block in. It fit okay. Talking about the male jacks. One was for the dummy. Oh, the dummy. He's talking about the things we made on Sunday.
Yep.
The dummy load.
Yep. Dummy load would go into
the male RCA connector.
It'd go into the antenna. You'd plug that into the antenna.
Yep.
And then
the other one was for the RF. No, not the RF. It was in the bag with the RF probe.
Oh, I made 2 I put 2 of them in there because there's 2 resistors in there. One is a 51 ohm 3-watt load.
Yep.
Okay. So you can make it not quite 50 ohms. You can use 51 ohms.
More power.
But it's a 3-watt resistor. So now you got a 3-watt dummy load.
Okay. So now, those male RCA jacks were for the dummy loads.
That's correct.
Yep.
Dummy loads. Okay. We sort of built those on Sunday.
Yep.
So at the very tail end of the whole thing.
We'll have them back.
We'll have them back
on Sunday.
Yeah. We'll have them back
At
on Sunday.
5 p.m. Eastern
And we're gonna use
Standard-
them.
5 p.m. Eastern Standard
Yeah,
Time,
5 p.m. Eastern Standard Time. Okay.
which is
And we will have them, and we'll show you how to use them and measure and all that kind of good stuff. Anybody else out there still building? Have we caught up with everybody? We got any more questions? We got a few more minutes before we
Got
have
one
to
more
start.
question. Do you trim the let me put it up here. Do you trim the crystal? Look how high it sits up.
Yeah. Yeah, you notice that I've got my crystal I trimmed it
right down.
a little bit too short, but ordinarily if you leave maybe that's a quarter of an inch, I'd leave 3/8 of an inch. And then you could, if you wanted to, take another lead and solder to the case in the middle and bend it down and then bend it over.
so it goes into that third hole in the connector.
And I'm doing it this way here just to show you. We still don't have a close-up, but you could make a phantom middle pin.
Just
Okay.
hold it up, like up in the air. Up.
Well, that's why I'm up here. I'm going to the overhead. See there's a phantom middle pin.
Yeah.
Okay, I haven't saw anything, but now you can ground the case, and actually they work a little bit better. Again, that's just, I mean, so many people have used the Tuna Tin too without a grounded crystal, but you can ground the crystal or not. Okay, it all depends on how persnickety you want to get. Some people are very persnickety. Straight key. I'll quickly.
We do that on Sunday.
We'll do that on Sunday.
Yeah, we're running.
Okay,
We're running to the end of the time.
We are. What? It's only been an hour and 40 minutes. What, are we bumping into your bedtime or something?
Yeah, we told people 2 hours. We rushed through the RF probe on Sunday.
Okay.
I don't know if we want to do that again because then
right.
we run up against the end of it.
You know what I might do is I might just build a straight key on my bench with a quick video, just shooting overhead while I build it.
We'll be here Sunday too.
We'll be here Sunday. Okay. We got to have something to talk about. No, but we're going to do some fun stuff on Sunday because we're going to have a scope. We're going to take some nice signals, and then we're going to vary this thing and show you how you can if your favorite band is 20 meters, we can get you on 20 meters. You're going to have to do some unsoldering. I do have an unsoldering video on my YouTube channel that is, I think, very useful. It shows you my technique for unsoldering, which I think is, I should patent it. I'm sorry, I used to be a toy designer, and we patented everything.
Okay, so I got those links in for the stands. I put those in the chat.
The tip and ring?
Yeah.
Yeah, okay.
What is that what it is? The tip and ring?
Tip and ring.
The X brass set. The brass set that you're talking about. That link is in there.
Oh, okay.
Oh, yeah. I see it.
And who is going to want to buy something? And how fast? No. Someone want to know how fast I can ship something, but I asked, what they're going to buy.
No,
they don't know. I got a lot of stuff on the shelf right now. I came down. I was housebound for about 2 weeks, so I spent a lot of time at the bench and I kitted a lot of stuff. So I have a lot of things on the shelf. If not, I don't have very many orders backlog. I think I got two orders I haven't shipped this month. So it did take a lot of time, getting all these things. And then I had to get all those capacitors out the door. Some people, I apologize, didn't get their capacitors today. Quite a few people did. But I think Oregon, I think Vero Beach didn't get theirs. I was watching them, but yeah, some took a very wacky route. I mean, Limerick to Portland to Rhode Island to New Jersey to Georgia. And I'm sorry, I think it's Sam, who lives in Charleston, South Carolina. I used to live in Charleston, South Carolina. Lovely town. I like Charleston. I still remember the museum when I was a kid. Had a big giant whale in the overhead. Anyway, I haven't been back there for a while. Okay, are we pretty much? I think we run out of questions. We run out of viewers.
I haven't seen any other ones come in. So.
No more questions. Okay, we're gonna call this a wrap for tonight, and hopefully we'll see y'all back here on Sunday? Huh? Bring a sack. Bring a
Okay,
sack.
everybody. Thanks, everybody, for joining. We will catch you next time.
Okay. All right. Thank you very much. Good night.